Right, we're going to look at a method again, a practical that you've got to know. Remember, it's not just lists of facts. This is a practical. It's called a titration, and it involves adding an acid and an alkali together to get a neutral salt and water. Sounds simple. Bit of acid, bit of alkali. They react together, you get some salt and water. But what this method does here is to make sure that it's only the neutral salt and water that ends up in this conical flask. If you add a bit too much acid or a bit too much alkali, the whole thing will end up a bit acidic or a little bit alkaline. If we get it spot on, the contents of this will be green, it will be neutral salt and water, and that is it. So if we use a universal indicator, it will be green. Okay? So here are our two reactants here we're going to use, and we put our acid down the bottom, say. You don't have to, you can do it the other way around, but we're going to have acid in the bottom, so we measure out a volume that we want. So say we'll measure out 20 centimetre cubes, so using a measuring cylinder. I'll stick that in there. And then we have a volume of sodium hydroxide in here. Don't say amount, always say volume. So we've got a volume of sodium hydroxide, and hopefully it gets to about 0. So we use a funnel and we pour it in there, and we make sure that this thing here, this is a stopcock, is closed, otherwise all the alkaline will run into the acid before you even started, which is not a good thing at all. So here we filled this sodium hydroxide up, and we've sort of decided, right, there's our starting point, and then we start to do our titration. And to do a titration, you turn this stopcock here, which opens up the burette, and you swivel this like this, and you mix, and you turn this off, and you mix the alkali and the acid together. You see if there's any change in colour, then you turn this a little bit more, change in colour, no, turn a bit more, like this, so on and so forth. I'll show you again in a minute. He's very important, watch out for him later. So here we've got the ionic equation again. We've got hydrogen ions from the acid mixing with the hydroxide ions from the alkali to give you some water. That's water here. Now it's ignored the neutral salt because it's the ionic reaction to show how an acid and alkali react. This AQ means aqueous, which means it's dissolved in water, and this L is for liquid. Now if we look at one here that's already been set out, this is the burette. This is an American spelling, it's just have a T and an E at the end of it, so really honest. And here we've got our sodium hydroxide, and here our hydrochloric acid. So what we said is you turn this stopcock here, and some of this goes into you keep turning it, or sort of shaking it gently until this goes green. Now it's really important that you use your eyes to know exactly where it started and exactly where it finishes. You've got to be precise. Precise means you're using decimal places, don't forget that. So you're precisely measuring how much of sodium hydroxide it took until this went green. That is the end point. You add a little bit too much, it's going to go blue because you're going to have that little bit of alkali left behind. It's no good at all. So we're watching out for an end point. She's good, isn't she? So we're watching out for that end point. Once you've done it, it's finished, it's gone green, you're spot on, it's not changing colour. You've recorded where we finished, we've looked at where we started, we know exactly the right amount of volume to put in. Okay, then you do it again, but this time instead of adding universal indicator, because otherwise we'll end up with a pink blob, instead of adding the universal indicator, you don't add anything because you know exactly where it's going to change. You know because you've done it already. So you set it all up again, measure out exactly the same amount of acid as you had before, pour in using the stopcock, and here this little shaking method, exactly the precise amount of alkali as you did last time, and you'll be left with a clear solution of neutral salt and water, and that's all it'll be. And it won't be green. It won't be green because it won't have any universal indicator in. Now how do we get rid of the water? Well, we all know that. Get rid of the water, we can heat it up a bit or leave it out, and they'll form crystals as the water evaporates, and those crystals will be this neutral salt. So if we add these together, what's that salt going to be called? Sodium chloride. Fabulous. If it was nitric acid, sodium nitrate. Sodium sulfate if it was sulfuric acid. So this is titration. Burette, exact end point when your neutral salt is formed. Do it again without the